yeah, so it's a really simple, straightforward Node.js, Node-bots thing. It's built out of cardboard, has a servo, dispense cat food. I brought candy to the conference so that people could, get candy instead of cat food. It was really accessible for people that had never, maybe wanted to speak at a conference and they wanted to figure out how they could do that, or how to get into Node and how to get into Node bots. And I made sure that my README was like the most verbose thing ever. So like even if you didn't know how to code, you could follow along with the instructions and get started. So I like to do that with almost everything that I do, if I can. So now I'm going to give you a little bit of a history lesson. It's basically the history of the early-ish internet for personal sites. Like the talk title references, this is the 90s, but we're going to go back about, oh, I don't like doing the math to when this is, but yeah, 25 to 26 years ago. So yeah, people were expressing themselves online in the 80s and 90s as well with like BBSs and stuff, but we're going to talk about the history of the personal site. And we can't do that without talking about Geocities and AngelFire. So Geocities was created in 1994 as a web hosting service. It was originally initiated as a beta program called Beverly Hills Internet. And the concept was to create cyber cities in which users would select a virtual city, and then they had like themes under that. So like Area 51 if you're super into aliens, or Rodeo Drive for shopping and stuff like that. And so people would create their personal sites there or fan sites for the thing that they liked that was relevant to that thing. And like I say thing a lot. You can find similar people that have interests of like what you have, and it was really nice. And so AngelFire was created in 1996 as a web hosting site, but it was also a medical transcription service. And once they saw like how the popularity of the hosting was taking off, they were like, all right, let's just stick to this. And so while Geocities had the neighborhoods feature for selecting your domain, AngelFire focused strictly on hobbies. So it would be like angelfire.com with 2 or more names and then directories that you would select from a pull-down menu. So you could have like, all right, I live in New York and I like Pokemon. So you would have angelfire.com/New York/Pokemon and then the text for whatever your directory was. And the key thing about Geocities and AngelFire provided to consumers was that it was an understandable way to get a site up and running. And I'm not really a fan of using words like easy or simple, but there really is no caveat here. They made it so it was really accessible to users. They both had simple control panels where you would be able to edit HTML files in a text box. Coupled with these simple editors, you would be able to find some other websites that you could copy and paste some code from. So you didn't have to code. And nobody was like judging you for that. If they were, you wouldn't hear about it anyway, which is kind of nice pre-social media. And if you were a little bit more code savvy, you could use FTP. So it was basically the best of both worlds, simple static HTML and images, and you were good to go. So there were a lot of little communities that popped up giving you those copy and paste snippets. So you could get like silly little cursors or have it snow on your web page. And it was just really about self-expression and having fun online, which I feel like everyone should always do. So now I'm going to show you some examples of these websites. So usually when I'm talking about old Geocities or AngelFire sites and I'm looking for images to use, I kind of feel like I'm stumbling on a stranger's diary because they were so personal. And like I shouldn't be reading it, but obviously, like they put that stuff out there. So the first one that I want to show you is Stephanie's Temple of Cool. She has a Hanson fan page, a Joe McIntyre fan page. He's from New Kids on the Block, if you know what that is, as well as a Fine Guy Shrine. She also included links to pages that had her friends on it and other resources where you could get cool things for your page. My next example is just called Cute Boy Site, and it says, this is a place for girls, but if boys want to see pictures of boys too, I don't mind. So, really ahead of the time. I love the sentiment here, and it ends with, I hope your eyes are going to have a great time, which is just, really nice. People were also making sites about sharing information, like this one, trying to teach other people how to create their own Doom levels. You don't have to watch like a 15-minute YouTube video to do it. You just get the info there. And then Jerry the cat homepage, and this was in the Pittsburgh neighborhood on Geocities. I like this one because Jerry the cat's owners wrote a lot of dialogue about the life of Jerry. So here are some of my favorites. The reason Jerry is so fat is because he can scalp food from anyone. If possible, he would gladly consume 5 or 6 normal meals. There's only one reason for this. He was raised by countless admirers who could not help but constantly feed his seemingly helpless butt. And then this snippet. Here's Jerry in the hands of his humble owner. It's kind of refreshing to know sometimes that he remembers. He's a cool cat, but he doesn't particularly like to be touched. And pats are always welcomed, but only for a limited period. Who knows what goes on inside the mind of Jerry the cat? So people would make sites for whatever reason they wanted. Who knows how many people would see it or how they would discover it. It's just something that you might have shared with your friends or family, or you would find it from the Explore section. We're not even getting into web rings. I'm not going to touch that. But yeah, so you could just find other pet lovers in the Pittsburgh section of Geocities, and it's really nice. And then in the early 2000s, a lot of things started happening that enabled the desire for more customization and discoverability. So social media started, specifically speaking MySpace in 2003, and MySpace allowed users to use HTML and custom images to be able to customize your profile right there on the site. You could also put in some special secret JavaScript that would help you see who was viewing your page, which was definitely a third-party service. So if you were a teenager, you were just like, oh, is my crush viewing my site? And then sometimes it was sad. And then, of course, Neopets, which was founded in 1999. Not a social media site per se, but a lot of people say that they got their start customizing their Neopets profiles. I still have Neopets, and they're old enough to drive, which, that's pretty cool. So now on the personal website side, we had something else happening in the early 2000s. And in November 2000, a blogging software named Gray Matter was created by Noah Gray. And it's referred to alongside CafeLog as being the inspiration for WordPress, which not a lot of people know. It's really cool. It was maintained by Noah for about 2 years and then taken over by a community of supporters. During that time, it allowed for more people to register and use it, and it didn't have a database. Its only requirement was that you had a web server that had Perl on it. So it allowed people to have much more control over their content. And I've spoken about this part of website history at length before, and if you want to hear more about that, there's a Medium article called Keep the Internet Weird, and it's also the title of a talk that I gave at JSConf.eu, which is way more about this kind of grungy personal site thing. But since the early 2000s, the idea of the personal site hasn't really changed that much. You've got an about page, maybe a blog, a few other pages for information about yourself, but the technologies have grown exponentially, and so has the barrier to entry. So content management systems like WordPress, Drupal, Joomla dominated the rest of the 2000s, and if companies weren't using these, they were rolling out their own custom MVCs that they never wrote documentation for. You had to start worrying about templating for your layouts, databases to store your content. It wasn't just as simple to click as a user who wanted to go in and play around, really, unless you were still using Geocities and Angelfire. Around 2010, we start seeing a lot more heavy emphasis on design systems when it comes to the front end, as well as a shift from PHP and Java over to JavaScript. And we're caring more about knowing stacks than just wanting to put stuff out there. Which is why for the 2010s, I'm describing it best as design in JavaScript times 1,000. The market just gets entirely saturated with JavaScript and various frameworks and libraries. Node.js in 2009, Express in 2019, Angular Backbone, you guys know, I don't have to tell you, we're at a JavaScript conference. So there was all at once a lot of different ways to accomplish the same idea. This led to, at least for me personally, a burden of choice and just a ton of documentation to read for you to just get up and running. And that's just the beginning, because now we have to worry about a system for our design as well. Paul Irish released HTML5 Boilerplate in 2010, and then we have to worry about Sass and Less, and a lot more CSS things, even more CSS libraries, tachyons, Bulma, Tailwind, et cetera, et cetera. So like no matter the thing that you're trying to accomplish, there's numerous ways to do it. So what are you supposed to do? What are you supposed to do if you're a person who's not super technical? And so sure, we can't really go back to exactly how easy things were in the 90s. We can go back to static sites and a more simple and streamlined developer experience. So Jamstack has made that, like, in my opinion, a lot more accessible for people. So Jamstack works by decoupling the front end from the back end, and before deployment, the entire front end is pre-built into highly optimized static pages and assets, and this happens all in the build process. So you can pick and choose your own technologies and simplify the steps that it takes from writing your code to it showing up on the web, and that's personally why I like it, because it reminds me of how easy it was to, just get a fan site for a pop punk band I like up and running and out the door in like 15 minutes. It really, makes it that streamlined. So here are some of the more popular approaches to Jamstack style development. You've got Next.js, which is a minimalistic framework for server-rendered React applications, as well as statically exported React apps. Hugo, which is a static site generator written in Go. Gatsby, another framework that allows you to create more minimal and fast React applications, which are also exported as static files. And then a ton more you can see at jamstack.org/generators. And I know what you're thinking. You just showed us a lot of technologies speaking about the burden of choice, and now I'm showing you even more. It's a little bit different. You don't have to worry about the server as much anymore. You don't have to know the full stack up and down. And hosting platforms like Netlify and Vercel make the process even easier. You just hook up your Git repository, and when you push to your branch, kicks off the static site generation based off of what tool you were using. And so you don't have to worry about the server's CI/CD, CDNs really, unless you want to. You can just write your code and you're good to go. So I had a site in my head for a really long time that I wanted to build, and I knew that I wanted to try Jamstack/serverless. And so let me show you what the project was, how I accomplished this, and how you can get started. So I've been to Japan a few times, and when I'm there, I'm obsessed with these photo booths, which are called purikura. And so in Japan, that refers to a photo booth that basically has a station where you take your pictures, and there's like a green screen, and then you come out and you decorate them, and it's really cool, and you get stickers. If you have a Round One arcade near you in the United States, they have them there. Highly recommend it. So it's just like a really fun thing to do with friends. And that's an example of the green screen one, and then you move to the next section, which is the decorating one. And this is the funnest part. You've got a touch screen with pens that allow you to move through each photo that you took and add adjustments to the photo. So like you can put on makeup, you can draw things, you can add a ton of fun stickers. And I really liked doing this with my friends. It was fun. So I knew that I wanted to recreate this experience, but how was I going to, capture that in a COVID world when I couldn't hang out with my friends at the time? So I made PuriBooth. PuriBooth is a React application generated into static assets. I'm utilizing WebAssembly for ultra-fast image filtering and Canvas for the photo decorating. It's hosted on Netlify, so I can just push changes as I need to, and it's automatically built. And I'm also using Datadog's real user monitoring, so I'm able to do some live A/B testing. Obviously, I'm not going to do a ton of user metrics for my own personal site, but it helps because I drew all the stickers and they're not that good. All right, so I'm going to give you a demo now. Where's my mouse? All right. Control tab. No. How do you get to another tab in a browser? Okay, you know what? I'm just going to hit escape and go to it manually. Oh, it's not there. Cool. There it is. All right, let's go back to full screen. So this is PuriBooth. It is puribooth.com, so if you want to try it out now, you totally can. It's fully responsive. It works on mobile. All right, so, okay, don't tell me what to do. All right, so basically you come into the site, you can either take a picture with your webcam or you can upload a photo. So I'm going to upload a photo of Nicolas Cage. And the next thing that I'm going to do is, add some filters. None of these images are stored because I don't want to deal with people doing things on the internet and being liable for that. So it's all just like local cache stuff. All right, let's give him, let's do let's make it cute. Let's rose tint him. And then let's go over to the decorate page. And so this is the canvas part, which is really fun to figure out how to do. You can basically select all of these. I'm going to make him a cat boy. All of the stickers you can resize, you can rotate, you can add them up and down, as if they were a layer. You can remove them if you want. Let's give them a little, oh, those are cherries, that's not a bow. Well, that's good, so I don't want the cherries, so I can remove that, and I'll just add a really cute heart. Obviously, I could go real wild on this. Let's just give them some more sparkles and call it a day. So then you hit Let's Share, takes it out of the canvas, gives you an image that you can save, and it's really fast, it's simple to use, and it basically achieves what I was looking for from what I missed with those websites that I could use, or not websites, photo booths that I used to use. So now let me show you how I did that. You come back over here. You go full screen again. All right, so that was the demo, obviously. So now I'll tell you a little bit about the technical details. I knew that I needed a simple React app and that all my components were going to be React hooks. It's a single-page application, so I wasn't worrying about any routing at all, which is kind of annoying if you need to start over, but it was quick. So to start up this project, I used React App Rewired. It lets you tweak the Create React App Webpack configs without using eject and without creating a fork of the React scripts. And it's got all of the benefits of Create React App without the limitation of no config, which was great. You can add in plugins, loaders, whatever you needed. And I did need some loaders for the image manipulation library, which I'll get into next. So I have a lot of experience with JavaScript image manipulation libraries. One particular one that I've used many times before and wish to never use again is called ImageMagick. And so it's not fun, and I was like, I'm never going to use it again. So when I started this project, I was like, I have to try something else. I'm sure there's going to be, some other image manipulation libraries I could use, like Cayman.js, Pika, Lena.js, or Compressor.js. But I decided to go a slightly different route for this because I just, stumbled upon, oh yeah, never again. I forgot I made a little animation. I really hate ImageMagick. And the route that I took was Photon. So Photon is an image processing library in WebAssembly that runs both natively and on the web. I chose Photon because it's 4 to 10 times faster than JavaScript. It also has over 90 functions built in already, including some filters, channel/color manipulation, resizing and correction. And so it took a ton of the heavy photo manipulation work out of the way. And there was also a quick start for Node. So it was really easy to grab the package and easily adapt it. I'm saying easy again, but you know what I mean. It was fairly straightforward to adapt it down to like the drop-down filtering that I needed. And the configuration override that you need for the WebAssembly to work with React was also in the Photon repository, so I didn't have to overthink that part either. And finally, the last thing, which is arguably like the most important part of the entire project, was the sticker decorations. It was also the most difficult when dealing with canvas elements. There's like a ton of libraries that are very finicky, very dated. Some of them aren't maintained. That's dated. They're dated. People don't keep up with it. And I did not want to write this from scratch. So I used fabric.js. It fit like all of the things that I needed for it. It allows for the images to be resized, rotated, and dragged. It supports image grouping, so you can mass delete items, and then you can also move the layers up and down as if it was like a Z index. So now that I have all of the technical elements that I needed, it was time for me to deploy, and this is where the title of my talk comes from. So I missed the simplicity of being able to edit all in one place and have my site be ready to go. And Netlify made the process like just how it kind of was, obviously a lot, well, not exactly how it was, but it like gave me that excited feeling of being able to get something out there in like a matter of minutes. And so since I was already using GitHub for my repo, I signed up for an account at Netlify. I don't work at Netlify, it's just great to use. I set up my domain to point at their servers and build and deploy. I set up my GitHub repo with the build command and the directory to be published once it's built, and that was it. Now, every single time I push to my main branch, Netlify knows, kicks off that build process and the deploy process. I don't have to go to multiple sites. I don't have to do multiple configurations anywhere. I don't even need to leave my code editor if I'm using VS Code with like the command line built in. It's really convenient and has inspired me to make more things. However, I did run into some issues once I started having friends and family testing the site, but obviously that's because I wrote the code, so they were finding my bugs that I did not. And so when I started letting people try it, I was noticing some errors that were only happening on mobile. I was also noticing some people were having different interaction behaviors with the images that I didn't expect, so I didn't have it supported. So, holding and dragging versus clicking. I needed to add in a draggability interaction. And so the things that my friends and family were telling me they were having issues with were easy enough for me to implement, but it would have been easier for me to have like a bigger picture view if I was actually gonna make other people besides my friends and family use it, and that's why I just threw in the monitoring to track user behavior. I put custom clickers on the images, and with a few lines of code, I could like A/B test in the browser and figure that stuff out, which was awesome and quick. And I know this says thank you, but I'm not done yet. So it was cool because I got to hire my friends. I commissioned my friend. Let's go back to the one that has like the picture of the Puri booth thing. I got to pay my friend to make this pixel icon for me. I got to pay my friends to make the stickers for me. So like, not only was I making something because I wanted to be able to be close with my friends when I couldn't, I was also able to involve them and like compensate them for it, which was really cool and fun. And so like, by way of all of these new-ish ways that we're able to, come up with an idea and get it out there in the world, it has like reinvigorated my creativity. And I hope that this will maybe, inspire some of you to like try some stuff that you haven't been trying out in a while and get it out there and get it up and going. And so I guess to summarize, while the 90s are back in style right now, you can also get up and running as easy as it was to get up and running then. And if you want to see the code for this, it is at github.com/RachelNicole/PuriBooth. Thanks.
Amazing talk. Can we do the Puri booth at some point? Yeah, cool. I want to be the cat person as well. I got two cats myself, named Dio and Donut. They're two little black cats. They're cute. But yeah, anyways, so it's now going to be lunchtime. So lunch is starting at 12:30. It's over in the Homestead lawn, and I want to give a big round of applause to Codingscape because they're sponsoring our lunch. So without them, we would all be hungry. So let's give them a round of applause. But I also want to mention that Dolby.io is doing a workshop at 1:30 at Heritage. I think it's at the same place as the last workshop, and you're going to be learning Babylon.js to build 3D metaverse environments. Ooh! So check that out after you're done eating. It starts at 1:30, and then I think what's it called? Yeah, I guess we're back here at 2 o'clock. So yeah, have fun, eat food, and see you in the 2. Oh yeah.
day that we've known each other, never make it on time. From the first day that we've known each other, never make it on time. Time to have my baby. And go, no more. Time to have my baby. And go, no more. Depend on me. 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 Don't depend on me. Depend on me. Depend on me.
Continuous integration is a software development strategy that increases the speed of development while ensuring the quality of the code that team deploys. How does it work? Every developer commits code in small increments daily or even more often to a shared mainline code repository. Every commit triggers an automated build and test of the code base. If the build or any test fails, it's repaired quickly, often within minutes. Continuous integration works hand in hand with agile methodologies. Team members work on incremental changes, and the code for these software updates is merged incrementally into the shared software repository multiple times a day. To get started with continuous integration, go to circleci.com today.
All right. I think we're good. So feel free, you can hang out on stage. I know you're setting up. Yeah, just let me know when you're ready, I guess. Dun, 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 dun. Looking good? All right, cool. So yeah, welcome back from lunch. Hope y'all are feeling well fed. I had the chicken wrap. I liked it a lot. Tasted really good. I like the cookie. I got 2 cookies, in fact, because someone forgot their cookie, and I was like, well, you know, it's mine now. So, but yeah. So welcome back. We're going to go back into the talks. Next, we have Triviacom. And their real-life superpower, fun fact, is that they're really good at planning in-person events like vacations. Maybe like something we're at right now, huh? I got to tell Carter. I got to tell the rest of the staff. But yeah, so please welcome Triviacom. Yeah.
Thank you, Aaron. Okay, thank you, Aaron. I am just good at planning like small events, like what, 10 people or for my team or for my close friends. Organizing a conference at this scale is very tough. And I would like you to give big hands to all the organizers of CascadiaJS. Thank you very much. Okay, so before we start this talk, I need to take a selfie because if it didn't happen on social media, did it actually happen? Thank you so much. And this is a generic talk about, okay, let me just start. So this is a generic talk about publishing in JavaScript ecosystem, how to keep everyone happy. And I see that all of you got bingo cards, right? So my talk is going to contain lot of words, yeah, like stack, stream, benchmark. Sorry, that would constitute as cheating. But let's start with the talk. So my talk is about publishing in the JavaScript ecosystem, how to keep everyone happy. My name is Trivikram Kamath. I am software development engineer with AWS SDK for JavaScript. And my Twitter handle is Trivikram, and my GitHub handle is Trivikar. Now, 80% of you would have forgotten my name by this point in time. And 20% of you will remember the stale joke which I used in the previous CascadiaJS conference. So let me use that again. So you know this beautiful trio of volcanic mountains west of Bend, these 3 sisters. Let's take 3 from there. And we are in United States where a certain style of yoga is popular called Bikram yoga. Let's take Vikram from there. So that's my name, Trivikram. Okay, it didn't land. That's fine. So let's do a reality check first. The reality check is you cannot make everybody happy, okay, in tech as well as in your life. But you can try your best. So let's try our best. So if you're active on social media, then hashtag CascadiaJS is the official hashtag. Since this talk is about publishing in JavaScript ecosystem, you can also use JavaScript, Node.js, and NPM. So why talk about publishing, right? Publishing seems to be a very simple step, right? No, it isn't, because there are so many browsers, Chrome, Firefox, Edge, Safari. Then there are servers, Node.js, Dino, Cloudflare Workers, Bun. Then there is JS native, React native, NativeScript, Flutter, Ionic. Then there is module formats, CJS, ESM, AMD, UMD. Then, oh my God, when is it going to end? Sizes, publish size, install size, bundle size. Then you have types, flow, TypeScript. Then you have debugging, sources, source map. Then there is observability, open telemetry, open tracing, and open census. If you want to take a picture to share on social media, this is the picture. I'll wait for 5 seconds. So my Twitter username is at the bottom of the slide, so you can tweet to me. I'm pretty active there. Yeah. And since this talk is in recorded format available on YouTube, you can just jump to whatever you are interested in. So let's see what we are going to cover. So we are going to cover which criteria affects your package, okay, because that is what matters, right? And evaluate why, how, and what of each criteria with some approximations based on data, okay. Note that these suggestions are based on assumption that you maintain a package on npm using package.json. We will mention Deno first packages in one slide if you want to give them a try. So which criteria will affect you? There is one answer, and that's the answer. It depends, okay? It depends on what and how of the problem solved by your package, and where and how do users want to use it. So every time you want to find the answer to any criteria, ask these questions. So let's see why, where, and how do users want to use your package, okay? Ask them, okay? And if your package is popular, they will tell you, they will find you, they will tell you, which is good. And you can also populate data in telemetry if your package supports telemetry. So let's see the publishing criteria, that is why, how, and what of browser, server, native, module formats, size, types, debugging, tracing, and I have 20 minutes. So criteria, browser. Why do you have to support browser? Because JavaScript is the language used for scripting in the browsers. Some of you might have sighed saying that there is WebAssembly, which allows non-JS code to run on browsers. But don't worry much about WebAssembly. It's going to be used for special use cases. Yeah, I don't think it'll replace JavaScript. But so how do you support browsers? So in your npm package, use the browser field, and then you tell where your browser code lies. It's straightforward. If a certain module is not there in browsers, let's say Boolean false, if certain module exists on browser in certain file, give that file path, or for server you can use clients. So what do you need to support? Isn't JavaScript support fragmented in browsers? Answer is yes, but there is a big but. That is, Internet Explorer has retired on June 15, 2021. So you don't have to support ES5. And Safari is likely getting competitive. EO is forming some draft rule about iOS monopoly of WebKit, and they're hiring also. So don't worry about browser support, it's going to become better. So now criteria, server. Why do you have to support servers? Because Node.js server you have to support because you have JavaScript developers who can write server code, so it becomes easy. You don't have to hire developers who are proficient in other languages. So in servers, Node.js is the most popular JavaScript server runtime. Not just JavaScript server runtime, it is one of the most popular server runtimes. So support Node.js. Deno is being used in more products. Last I heard, Supabase, Netlify, and Slack also are planning to use Deno. So that might be important to you. Cloudflare Workers is going open source, finally, after 4 years. That is good news. And we have a new kid on the block, Bun, which is very viral right now because they have prioritized performance and npm support. So let's see, is it bad that there are so many competing server runtimes? Because they have a competing browser implementation also, right? No. Why is that so? Because now there is web interoperable runtimes community group, which Deno, Node.js, and Cloudflare Workers are part of. So they are trying to standardize how a JS server runtime should work like. So there, it's a good news that there will be standards in JS server runtimes also. So let's see how of Node.js. Just add file path in the main entry of package.json. That's how you support Node.js. How do you support Deno? So Deno, good news is Deno 1.25 added experimental NPM support, and they're planning to prioritize it over the next 3 months. So hopefully your NPM module will just work as it is, and you don't have to make much changes. And if most of your users are on Deno, then you can publish your Deno module on NPM using DNT. So you can write a Deno module and then use DNT to publish to NPM. How do you support Cloudflare workers? Any Node.js package that uses Webpack or another polyfill bundler runs in Cloudflare workers, so you don't have to support that separately. How do you support Bun? Don't. Bun natively implements many Node.js and web APIs, and it's very new. Okay, so as of August 2022, it's pre-alpha. Their parent company is aiming stable release by Feb 2023. So look out for updates and then decide. And also, it supports most of the Node APIs, so it should work out of the box. So let's see what you need to do. Again, it depends. Support the server runtimes that users want. But since Node.js is more popular, your users will most likely need Node.js. Now let's talk about JS native. What is JS native? So you write in JS native frameworks, you write JavaScript code, but the UI framework creates native apps. So it's very beneficial. You don't have to employ Android developers and iOS developers separately, or Windows developers. Just write JavaScript code. It works mostly in most platforms. So progressive web apps have some limitations like lack of push notifications. That's how JS native frameworks are helpful. And JavaScript native performance trade-off have significantly reduced over last 5 years. So now your JS native applications won't be that terribly slow compared to native applications. So how to support Node.js? How to support JS native in your module? So React Native parses code from .native.js or TS files, so you can write your native specific code there if required. I could not find how it happens in NativeScript, Flutter, or Ionic, so you just have to read that documentation. So let's see what of JS native. It depends. Support the native frameworks your users want. React Native apparently is most popular right now, so most likely you have to support React Native. Now we come to module formats. Everybody is waiting for this. So modules are building blocks of software, and module format is a syntax used to define a module. When JavaScript was getting popular in early 2000s, there was no standard module format, and multiple module formats were developed and used in parallel. So just a warning, conversations may get heated when opinions are shared about module systems, so take suggestions with a grain of salt. So which are the module formats? ESM is ECMAScript standard format. Module format is official standard format. CommonJS is original module format supported in Node.js. There was AMD asynchronous module definition specifically made for front end, and universal module definition specifically made to work universally. Those are not that popular right now. So how do you support module formats? If you're supporting a single module system, add that file part in the main entry. So this is where your code will lie. Okay. In case if you're using TypeScript like distributable file main.js, that's where the code lies. But if you're supporting both CommonJS and ESM, then you have to use export maps. So you have to say exports, and for import you have to tell where the ESM code lies, and for require you have to tell where the CJS code lies. Now how do you support CJS ESM? So you can also use ESM module wrapper. So that is, you write everything as CommonJS, that is exports.name value, and then you write a new file, index.mjs, which imports the CJS module and exports it as ESM module. I personally prefer the dual packaging, but it's up to you, whatever works for you. So you might mention you might have to write this code again, CJS code and MJS code duplicate code, but there is a module called Gen ESM wrapper, which Anna wrote. that allows you to create ESM wrappers for any CGS code which you want to export. So ideally, you should only support ESM. I thought somebody will throw a shoe. Okay, but this will break your users on Node.js whose application code is written in common JS format. So be a good citizen of JavaScript ecosystem and support both CJS and ESM if you have to support Node.js. So sizes, then we come to sizes. So what are the sizes, different sizes? Publish size is the size of the package which you publish on NPM or the registry. Install size is the size of the node modules folder when your package is added as a dependency. And bundle size is size of the file generated when a bundler is used on the application code for your package. Bundlers are usually used for the front end. So why do you have to worry about sizes? So if publish or install size is small, your install will be faster. So that's one advantage. Then your package will have smaller carbon footprint, which will become important in next decade. Adding your package will not exceed the size limits in resource constrained environments like serverless or IoT devices. And if bundle size is small, the load times of the final application will be faster, so your users will use your package if their size is small. So how do you reduce publish size? Write minimal code needed to just fix the problem. Okay, don't write some additional code which is not that useful. Use package.json's files entry to only publish required files, thus removing unnecessary files. You don't have to publish tsconfig.json, for example, if you are transpiling your JavaScript code. Consider moving TypeScript types to definitely typed. Okay, TypeScript users will not like this because they want everything to work when you download the package. But then if you want to reduce the publish size, this is something you can consider. I'll tell you how it happens. If you're using TypeScript, you can publish sources and source maps in debug variant of the packages using distags. I'll come to this later. So that way, your default variant will not have sources and source maps. So how do you reduce install size? So have minimal, install size is a size. Have minimal or no dependencies. Okay. Share tips on reducing the install size with the packages you depend on. So their install size will be smaller, and your package install size will be smaller. Provide a variant of your package just for resource constrained environments using a distag. So I'll show you how it works. So if you have a scope package name, that is the default variant of the package, that contains code for all platforms. Okay. And then you can create node variant of your package which only contains Node.js specific code. Let's say you only want to support common JS and not have ESM or not have types. That can reduce the install size. So how do you reduce bundle size? There are multiple tips here. Make your package tree shakeable. That is, bundlers will use the dead code elimination and reduce the code which is not being used by your users in the application. Use named export, so it becomes easy to just include the code which is required. Publish a ESM version of your package. There are multiple bundlers which are ESM only, and they are doing pretty good job. So yeah, provide a ESM version. And make your package side effects free. That would also help reducing the bundle size. And final thing is you can split your code into multiple smaller modules. That will have its own set of problems, but usually it is better to have modular packages which does just one single thing. So let's see the what of sizes. It depends. Okay, again, like you will come for this talk and like, oh, for every criteria Trivikram just said, it depends. So it's always good to have a small install publish bundle size, but still see like whether it's required for users, whether you should spend time on it. So let's see types. So JavaScript is dynamically typed language, and types are checked and errors are only spotted at runtime. When TypeScript was introduced, they did some research and found out that 15% to 38% of the bugs can be prevented by types. So using types, IDEs can provide code editing features like code completion and parameter information. Because of this, your users might want to use types and primarily TypeScript. So why do you have to support types? Because TypeScript is the most popular type system in JavaScript. And there is an ECMAScript proposal for TypeScript annotations but it will take time to get standardized and get supported across all JS runtimes. So how do you support types? So either write your code in TypeScript, okay, if you like TypeScript, or generate types from comments for your JavaScript code by running TSC. The types can be linked in the types field in the package.json if you want to publish your types in default variant, or if you want to submit your types to definitely type, then it can be published under types organization npm. So you might mention, isn't this going to make it difficult for your users to use TypeScript? Do they have to add types as a dev dependency? There are certain package managers like Yarn does it automatically, so you don't have to worry much about that. So what of types? It depends. Maybe I should copy this slide and just say title. So your users will most likely need TypeScript types, so you are most likely have to publish TypeScript types. So debugging. So let's see why of debugging. That is, if your package code is in a language which compiles to JavaScript, like if you wrote code in TypeScript, but you have to publish JavaScript code, right? They need to publish source code and source maps to help with debugging if somebody needs to go through your source code. So it helps users to debug through the readable code. It improves the understanding of your package because they see the code written in the language which you wrote in, and helps them unblock themselves if they are blocked, or they can create relevant bug features, bug reports or feature requests that would help you fix those bugs or work on that feature request. So how does it work? So you can generate the source map for your types, for your files in TypeScript config. So in TypeScript config, you have source map true or inline source map true that will generate source maps. And you can include TypeScript source by mentioning source root where the source exists, or you can just publish inline sources, which will just put source code below your transpiled code. So let's see what you need to do in debugging. So if your package code is in language which compiles to JavaScript, do provide sources and source maps. And if it cuts into your installer publish size quota, release a debug variant using debug distag. Just like we talked about node distag, you can use debug distag. So let's talk about observability. What is observability? Observability is the ability to measure systems' current state based on the data it generates, like logs, metrics, and traces. Observability helps developers build faster, stable applications. So back in mid-2010s, there were competing APIs like Open Tracing and Open Census. In 2019, luckily, they got merged into Open Telemetry. So let's see how Open Telemetry works. You can add out-of-the-box support for Open Telemetry, or add an instrumentation in an external package. So this is how your users will write code. That is, it will import trace from Open Telemetry API. Sorry, not users. Your instrumentation code will be written like this. You import trace from Open Telemetry API, and then you create a tracer, and you create a span, and you tell how long the span works. I should probably have put one screenshot here. So what do you need to support? So add external instrumentation for your package, either in your NPM scope or in OTel. So that is my recommendation. You can add out-of-the-box instrumentation also, but that will increase the all publish install size, and you will have hard dependency on Open Telemetry if things change in future. So the external package can be named as your scope name, Open Telemetry instrumentation, if you are using a scope, or if you want to put the code in Open Telemetry GitHub, then you can create Open Telemetry like instrumentation package name. So conclusion. Wow, we have how much time? 3 minutes. So let's talk about what the opinionated conclusion I have provided in this talk. So browser support only modern browsers ES6+. Servers support Node.js with optional Dino or Cloudflare workers support if your users need it. For JS native, it depends. Okay, ideally you have to support React Native. For module formats, dual perform dual packaging of CJS plus ESM, and you can also provide a ESM only variant if your users need it, because some people just want to use ESM. So then for sizes, aim for smaller publish installer bundle sizes in general. And for types, at least publish TypeScript types, and optionally use TypeScript to write your module if you're happy with it. For debugging, provide sources and source maps in debug variant if you are not using JavaScript for writing your module. And for observability, write a open telemetry external instrumentation package. So I'll wait for 10 seconds for you to take this picture, because this is another photo which can be shared on social media. We have 2 minutes remaining. Yeah. Okay, so thank you for listening. My name is Trivikram Kamath. My Twitter handle is Trivikram, and GitHub is Trivikar. You can find me there. And this is where slides are. We have AMA channel on Discord, so you can ask questions on AMA Trivikram Kamath. Yeah. Thanks.
Amazing talk. Yeah, I wouldn't throw my shoe at you. It's size 13. That would kind of hurt. I don't know. But so do we have Eddie? Okay, there they are. Okay, cool. I was almost had a panic. I was like, oh, I have to make jokes. Oh no. But yeah, so for our next talk we have Eddie. And their fun fact is that they listen to a lot of French hip hop while they code. And that's a life hack. If you are the type of person to write code and you listen to music and then like you write down the words as you write, try a different language. Because if you don't know the words, then how can you write it down, right? All right. Anyways, welcome Eddie, please. Yeah.
Is good? Do you see it? Yeah, all right. You never know with Linux, right? Cool. So, how's it going, everyone? Like you said, my name is Eddie Zaneski. I'm a software engineer at a company called ChainGuard, where we do open source software supply chain security. I'm actually a maintainer of the Kubernetes project. That's what I spend most of my time working on. And you can find me everywhere on the internet at Eddie Zane. So Twitters, GitHubs, emails, all those things. And we're going to talk about how cryptography isn't scary, it's fun. Except I have to give you a really scary disclaimer to start. I am not a cryptographer. We'll get into more about why I'm giving this talk in a second, but everything I'm showing you here today, take as an educative purpose. Don't copy paste this and pipe it to production. Anytime you're doing authentication, anything with crypto, don't roll your own, right? Use a service, talk to a professional, work with a cryptographer. So again, don't try this at home, except if you're gonna have fun and stuff. So cool, everyone promise? I made my cryptographer a deal. Okay, cool. So why give this talk, right? So I'm not a cryptographer, and I just joined this company that I'm working for back in March, knowing nothing about security. And so how do you go from working on distributed systems and containers for years to working at a computer security startup without knowing anything about security? And so I went on this big research sprint and just tried to learn and teach myself as much as I could. And that's something I love doing, is just learning new things. And so as I was learning more about cryptography, in the back of my head, I'm always thinking like, oh, like you have to have a PhD in math to be able to do this, or it's not for the pleb. I should never touch anything to do with a hash or encryption function. And that just turns out to not be the case. Again, consult a real cryptographer. But the idea behind cryptography is actually super fun. And there's a lot of cool primitives and higher level ordered things that those smart cryptographers have built that we can play with. So quick rundown on what we're going to talk about today. We're going to go through some terms, talk about keys, talk about this awesome thing called Diffie-Hellman Key Exchange. We'll look at how crypto works in JavaScript in the browser and Node. We'll talk about this potential really cool story of Nsa Backdoor. It's my favorite story that I come across while learning. And then we'll talk about some cool stuff going on with NPM and this other project I work on called SigStore. So if you talk to a modern cryptographer, they're going to tell you, we have a handful of things that really make up modern cryptography. And so we have this idea of symmetric keys, right? So a symmetric key is a key that we agree on ahead of time, and it's shared for encryption and decryption, right? So we agree on this key, and it's just the one key to rule them all when it comes to a cipher or any kind of text. And that's cool, but it doesn't always work because that's a single key that can get leaked. If everyone has a copy of this key, it's pretty dangerous. There's pros and cons to do it. So we also like to do what we call asymmetric cryptography, or private key, public key crypto. If anyone's ever used RSA before, or SSH, you've used public key crypto before. And so this is an idea that you can derive some private key, so depending on the key type. So you come up with some secret, and from that secret, you can derive a public key. And so that public key can always be tied back to your private key. So if you sign something or encrypt it with your public key, only the person who owns that private key can decrypt it or verify it. We also talk a lot about one-way functions. These are mathematical functions that are easy to go forward with, but really hard to reverse. A lot of this comes down towards prime factorization. So you take two really big prime numbers. A prime number is a number that can only be divided by 1 in itself, and you multiply them together, and so you have this huge number, and then to go and reverse those two numbers out of that huge number is really hard. It's a discrete logarithm problem. So we rely really heavily on these one-way functions. And also pseudo-random number generators, right? So computers, they're sand that we've tricked into thinking, right? They can't actually be random. They only do what they're told. And so when it comes to randomness in your computer and your software that you're writing, it has to use some source of randomness, some source of entropy, as we'll call it. The modern Linux and Unix kernels will have a pool that gets picked up from every mouse movement, every keyboard press you type, every packet that gets sent over the network. It pools all of that randomness into a source that can be pulled from for cryptography. And so these last two are really important because modern cryptography stands on the shoulders of these two, right? If those one-way door functions become realized, like, oh, there is a secret shortcut to undo it, like, the world will end, right? Like, it will be completely terrible. Same thing with pseudo-random number generators. If for some reason you're able to reverse this random number generator and predict the next number out of it, like, you've broken all of cryptography today. So RSA is, this is the reaction you'd get if you talk to Zach, who's the cryptographer that I work with, when you talk about RSA. It was great when it was invented back in 1970-something. It has since then been replaced, basically, right? So the way that RSA worked was with that prime factorization with a lot of modular arithmetic, which I'll show you in a second. And so RSA was great when it came out, but it's time for something new, and new things exist that are proven stable. So that's what we're going to talk about for RSA. So modular arithmetic. Anyone remember doing this in school, math class? Maybe a little bit. Anyone ever used a percent operator in JavaScript? Yeah, you've done modular arithmetic. Hey! So this is the idea that we take a number, and instead of doing division and figuring out how many times a number goes into something, all we care about is the remainder. And so if you see here, if we take 13 mod 12, we get 1. So 12 goes into 13 one time, and there's 1 left over. 14 mod 12, there's 2 left over. Makes sense. 28,000, big number, mod 12, there's also 2 left over, right? So if I give you a key or some sort of secret that says, hey, like, whatever my secret is, mod 12 is 2, you have no idea if you started with 14 or if you started with a massive number, right? So this is also one of those one-way door functions that's really hard to reverse. And so we use modular arithmetic in all sorts of cryptography. You just sprinkle in a little mod math when you want it. And so what's recommended today is this thing called elliptic curve cryptography, or ECC. So I came across this felt pretty fitting. I'll give you a second to read it. I thought this was funny when I was Googling it. Right, so elliptic curve looks like the picture on my right there. It's sort of a bell curve, right? It's in 2 dimensions. And so when we work with elliptic curves, these are not just someone your teacher gave you a random math problem to solve. This is a really researched piece of cryptography, a really researched mathematical formula. The basis of all of them is this y squared equals x cubed plus ax plus b. You never have to remember that ever again. Does anyone know what this curve is used for? Anyone recognize that? Bitcoin, I knew someone would. So this is the curve that is used for all of Bitcoin, all of the public blockchains. So all keys are derived from this single curve, right? And you can see here that these are the parameters that define this curve. So this is probably the most well-known curve in the world. It's recognized by most of the government agencies just because of its usage in crypto. And so what I found really interesting was learning about this is how these keys are generated, right? We're no longer generating like really big prime numbers. We start off with a curve, right? So we agree on a curve. That curve has a public point called P. You can see that in here. It's also sometimes called G. It's that point right there, this third from the bottom. And so we agree on this P/G point. And then we come up with another random point. So sometimes you'll draw a tangent line and figure out where it intersects, or you can pick one at random. And so let's say we wind up with this Q. This process called the dot function, that's what it's referred to in the formulas, is we draw a line from our generator point to our random point, and it will hit the graph at most one more time, right? And so if it does, we call that R, or negative R in this case. And then we do a reflection down to the x-axis, and we come up with the real R, right? Or you can call this 2P or 2G, right? And so we just keep doing this over and over again. And so now we have 3P, right? And so you can imagine that as we wind up with a point on the graph, and I say, hey, what number P was that? Well, that's actually really hard to figure out, right? And so that is actually what our private key is. And so the solution for public-private key for elliptic curve is the coordinates of this point is our public key, but how many times we did the dot addition function is our private key, right? And so you imagine just at a huge, massive scale, this is another discrete logarithm problem. It's very hard to solve. So I thought this was super cool and very simple as a sounding point for giving a key. All right, and here's a quick animation of how that looks. You just do this over and over again until you wind up with a huge enough point. Well, the reason that we use ECC instead of RSA is that computers have gotten smaller and they're everywhere, right? From factory equipment to a super genius device in your pocket. The problem with RSA was to get stronger with RSA, we had to keep increasing the bit length as computers that could brute force and break these keys are hard, right? And that's why this one-way door function is so important, because it is only possible right now to brute force a solution, right? There's no shortcut. So you can see as RSA key length has grown, you can get the same amount of security bits for a much smaller key for ECC. So this is one of the main reasons that people recommend ECC. And so that leads us to the Diffie-Hellman Key Exchange. Has anyone heard of this before? You use it every single day, multiple times a day. Anytime you make a web request in your browser or your phone, this is how a TLS connection or SSL connection is established between your client and the server. And so it's a way that we can agree on a symmetric key over an insecure channel, and it allows for future symmetric key encryption. So this is a very simplification of it, right? And the way this is explained usually is with colors. So let's say that we have Alice and Bob who want to communicate, and there's Eve, who's a nefarious third party who's always listening. And so we obviously have to communicate in the open to start. And so we agree on a public color, right, or that public point on that graph. So everyone knows this color, even Eve. And then Bob and I will pick a secret color, right? So we each picked a secret color. If anyone's colorblind, I tried to put the words on there, so I'm sorry. And so then we take that public color and our secret color, and we combine them, right? So we get orange and green. We swap those, right? At that point, it is a public piece of data. Eve winds up with orange and green. But the neat part is that we also have our private key, so I can mix in my red from that green that Bob gave me, and I get brown. Bob can do the same thing on his end with the orange I gave him, and he also gets brown. Eve can't get brown, right? Eve has no idea what that secret color is. And so this is basically the same thing extracted on that elliptic curve. And so I'm going to show you real quick, as a reminder to open the console, that if you ever look inside of your tab, in the security tab, you'll see here, under this connection bit, this says, this connection to the site is valid and trusted using QUIC, which is a protocol, X25519, which is a curve name. It's the Diffie-Hellman Key Exchange curve name. The X is for the exchange. And then we have this AES 128 symmetric key encryption, right? So that's pretty much what we did in here. And so an example of what this looks like in Node's crypto library. So quick disclaimer on Node's crypto library. It is very old, right? Node as a piece of software is pretty old. And it's built around OpenSSL, which you've seen updated when you brew update many times, and maybe it breaks everything. But Node relies heavily on OpenSSL, and it has grown as an API surface. So you'll find many functions that are called the same thing, but take different parameters as they realize how to actually do this. So this is what this looks like in Node, right? So we import crypto, we generate that key pair using that curve name. Alice and Bob both get public and private keys that we can pass into this Diffie-Hellman, right? We can swap my public key and Bob's private key. And then at the end of that, we get that secret that we agreed on, right? So this is our AES symmetric key encryption. So we have this shared key, so now what do we do? And again, this is what your browser is doing in a very, very high-level summary version, right? So we have a secret. I can take that key. I only need 16 bits of it, so we either agree to take the first or the last 16 bits. Then we have to generate this initialization vector, which is just kind of random data. The thing with hashing functions, like SHA-256, is the input is always going to be the same for the output, right? So if you always put in a file with the same contents, the output will always be the same. That's why we can use hashing functions to verify file integrity. The problem when you're doing cryptography is if you're using the same inputs for the same outputs and you see the same thing coming across the wire, it's pretty easy to guess. So we inject a bit of randomness at the front there. I use my stuff to create a cipher, update that with my secret, usually just stick that IV onto the front of your encrypted text. It's considered public data, and then your client will reverse it, or the browser will reverse it. Cool, makes sense. Quick demo. You can see I generated those keys. You've seen, this is a key encoding protocol called PEM. And so you've probably seen this before if you've done your SSH keys, uploading to GitHub or a server. Right, so there's our public and private keys. We agreed on that same shared secret at the end of the day. And then we do our crypto ciphertext, and our output is the same. Cool, that works. So that's Node. So what about the browser? Well, the browser's actually come a really long way. The Web Crypto API has 3 high-level top things. There's this get random values bit where you can give it an array of like typed unsigned integer 8, and it will fill it with random numbers. Random UUID will give you a v4 UUID, which is cool. Again, this is baked into your browser. You used to have, if anyone looks on Stack Overflow, you'll find this like crazy regex to generate UUIDs that people used to recommend. Now it's just built in. And then there's the subtle crypto library. It's what's called subtle for a reason, right? Again, back to that disclaimer. It is really easy to shoot yourself in the foot because these functions and these methods have subtleties to them. So when you look at the MDN docs, you'll see big, scary warnings. But these are all the things that are supported in the browser, right? So it might be tiny, but you can sign, verify, and there's the key types that work with it, encrypt, digest. So it's pretty full-featured, and the API is great. So definitely recommend checking that out. Again, this is that subtlety. So if you go to MDN's docs, you'll see some scariness there. But as far as crypto goes, like you can do a ton in the browser. So that leads me to my favorite story, which is this possible NSA backdoor that may have existed. So there was so get back to those pseudorandom number generators. This is what do they call this? A cryptographically secure pseudorandom number generator, so CSP stuff. And so this was a way that the NSA came up with to generate random numbers. And it works based on elliptic curve cryptography. And so you don't have to care too much about this, but what's important for a number generator is it needs to maintain some sort of state. Internally, right? So it knows what the last number generated was, and it can feed the last number it spit out back into its input to use for more randomness. Well, NSA came up with this, and they showed a bunch of people how it worked, and then I think people were super skeptical from the very start. Within a year, 2 cryptographers from Microsoft basically were like, yo, this is super shady. There's a potential backdoor in here. And so, again, this little flow graph here, right? So S is our state. S times P is that point on the graph. R is the randomness that comes out. And you take that random number, you multiply it by Q, and then you truncate the last 16 bits of it. 16 bits is pretty insignificant. So that was their first red flag, was like, you're not taking enough bits out of this. But if you spend enough time researching and reading this, P and Q this is a decent cryptography pseudorandom number generator in theory, right? Like, if P and Q are truly random. But let's say that P and Q aren't random. Let's say that actually P is influenced by Q, right? So let's say that we came up with Q and another number, E, multiply that together to get P, right? So in theory, this E might exist. Well, if that E exists, and you do some association property on this, you wind up with that E times RQ equals R times EQ. And then EQ is, as we already said, P, right? So now we have RP. So we basically found the internal state of that pseudo number generator, right? And if you have the internal state, if you can predict the internal state from that output, you can guess the next number. And again, back to the start, cryptography is broken, right? So, okay, cool. It gets better, right? So this is 1,000 times slower than current modern ways that we generate random numbers. Cool, okay. If it's better, better generation, maybe people will use it. It doesn't matter that it's that much slower. Cool. Well, the NSA came up with that P and Q. Okay, cool. Like, before Snowden stuff, we used to trust the NSA to do crypto for the US government. Cool. NSA wouldn't tell people where P and Q came from. They wouldn't tell them how they arrived at those numbers. So it got a little sussier. NSA then paid the RSA company $10 million to make this random number generator the default in the Be Safe security SDK that RSA publishes. So now you got money changing hands. And then on top of it all, NIST is the National Institute for Standards and Technology. So NIST worked with the NSA, and the NSA basically forced NIST's hand to say, you are only FIPS compliant if you use this P and Q out of our numbers. Right, so as you learn more about this, it just becomes shadier and shadier. And modern cryptographers are absolutely convinced that this E exists and that the NSA knows it and that there is a backdoor. When the Snowden docs leaked, it all as well confirmed that this happened. Really, really encourage you to check this out. It's probably the best story that I've heard in a while. Computerphile has a great video on it, as well as this blog post is really good. So I have a link to the slides at the end. And so that brings us to SigStore. Has anyone heard of SigStore yet? No? OK, that's awesome. So SigStore is a new standard for signing, verifying, and protecting software. And so SigStore is a Linux Foundation project, spun out a sub-foundation called the Open Source Security Foundation. And we like to describe this as Let's Encrypt for signing, right? So Let's Encrypt kind of took the web from having, what was it, like 20% SSL certs to we're at like 80 or something now. And so that's the idea behind SigStore, because developers managing signing keys is hard, right? Like, it's hard to keep a key. What do you do when you get a new laptop? Do you copy paste it? Do you put it on a USB drive? Are you sure you wiped it? Did your key expire and you forget to rotate it? We see people all the time forgot to renew their SSL certs or their domains. So just keys in general are really hard for developers to do. And so SigStore has a bunch of different components. The most notable to talk about is this Fulcio component. It's what we call keyless signing. It's this idea that you can tie a public identity, so through OIDC, to a crypto key. And so I can go and I can log in OAuth to GitHub, get a one-time use signing certificate that's tied to my GitHub account, and that key is only valid for 10 minutes. So it really doesn't matter what happens to it afterwards. And even though it expires, it all goes into this public transparency log that can be verified, that Eddie had access to this signing key because of his GitHub account within this window. There's also some other components in here for container signing and git commit signing. But the best is SigStore.js. And so this was built by Brian DeHammer, who's on the package security team at GitHub. It was donated to the OpenSSF and the SigStore project by GitHub. So big shout out to them. And the cool thing here is this has provider support built in. So inside of every GitHub Actions pipeline is a OIDC token that identifies your, OIDC is like OAuth and OpenID Connect. It's built on top of the OAuth spec. And so in every single GitHub Actions pipeline run, there is a token that identifies the run, your commit SHA of your code, basically everything. And you can take this token and exchange it for things. So this is great because inside of our pipelines, we can exchange this tied to a user, tied to a actions run for a key to sign with. Really cool. So there's support in the works for other providers, and we encourage other CI/CD providers to get involved. And we're always looking for new contributors. The reason I'm bringing all this up is there is an NPM RFC out right now called RFC 626. It is an RFC for linking packages to their source and build. For the sake of time, you can link public NPM packages to the source code repository and build it originated from source, making it harder to execute package hijacking attacks or malicious versions. Right? So this is the idea that someone compromised your NPM credentials, you don't have 2FA, and they published a malicious package on your account. A little different from what happened with LeftPad and some of the other things out there. But this is a very real-world thing. And this actually happened to the Python community last week. I don't know if anyone follows that, but the Python maintainers and PyPI package maintainers were subject to a spear phishing attack, and they had their credentials stolen and a bunch of malicious packages published. So this is the kind of thing that SigStore would prevent. And so real quick, I'll show you. We can npm pack this SigStore package, and then I can sign that. It's going to pop up in my browser that I want to OAuth, so OAuth with Google. It'll do the exchange, give it back a key, and then I got a signature for this package. So I can grab that log index ID, and this is the important part. So I could show you here that this is the cert and the inclusion, and you can see that this was signed by my email address. Really cool project. A lot in the works right now, so check out the NPM RFC. Before I get thrown off the stage, if you want the copy to these slides, you should take out your phone and scan this QR code. If I can get it real quick. And that's what I have today. So find me afterwards if you want to learn more about SigStore, how you can get involved. Again, it's an open source project, part of the OpenSSF and Linux Foundation, and we need all the help. So thank you.
Yeah. You still had 1 minute. You had 1 minute left. I wasn't going to. I got you. Don't worry about it.
You good? We're good?
Yeah, we're good. Yeah, we're great. So do we have is Joyce here? Oh, okay, cool. They're awesome. All right, awesome. I was gonna make a pun about your. Oh yeah, I was gonna say, Eddie, could we? If you ever start a YouTube channel, can we do like a tier list of all the elliptical curves of which one's like S and A tier, maybe? Oh, cool. All right, awesome. Yeah, feel free to set up. But yeah, next we have Joyce. They're from San Francisco, and you're with Postman, correct? Yeah, awesome. Well, yeah, I'm really excited for this talk, and please, let's welcome Joyce as they set up.
So sorry, it's going to take me a while to set up.
Yeah, I can do that.
You guys see this? If it's here, yeah.
All right, I'm doing a comedy routine.
Please tell us jokes.
So this isn't my joke. There's a buddy of mine I used to work with at Amazon. Their name is Joe, and their joke is, do you ever think at the end of hip-hop music videos, the director looks at the camera and yells, "That's a rap"? I like that one. But yeah, how you doing?
More jokes.
More jokes? Oh man. What's another good joke? Does anyone does anyone in the crowd have a joke? I can run over. Oh, let me run over. Yeah. Audience participation. Someone told me about this once.
The second screen on? Nice.
Cool. And let me confirm, this is a safer work joke, right? We're not gonna. Okay, cool. Go for it.
Knock, knock.
Who's there?
Owls go.
Owls go?
Owls go.
Owls go?
Yeah, owls go who?
Owls go who? Anyone else? Are we still setting up? All right, cool. Running around, dun, 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 dun. I feel like I'm like in an action movie or something, you know what I mean? Go for it.
How do fish talk to each other on the internet?
Fishing, maybe?
C-mail.
C-mail. That's good. I like that.
It's all right.
We're good? No? Okay. Anyone else? Oh, in the back. All right, cool. Hey, I'll stop by Daphne and then go over there.
What do you use to make iced coffee? Cool beans.
Cool beans! Yes!
It doesn't work. I don't need it, but
All
I'll
right.
need to set up.
One more. Let's do it. I'm running. Da-da-da-da-da. Go for it.
Why can you never trust a staircase? They're always up to something.
Oh my God, this is great. Can we just do this for the rest of the conference, Carter? Cool. Anyone else? All right, cool. We could do this all day. I'm loving this. All right, who had their hands? Okay, cool. I'll go over there because that's closer technically. Da-da-da, da-da-da. All right, there we go. Cool.
How did Darth Vader know what Luke Skywalker got him for Christmas? He felt his presence.
And then someone over here. All right, there we go. Cool.
So classic, why was 6 afraid of 7? Because 7 ate 9. But why did 7 eat 9? Because it was told to get 3 squared meals a day.
A math joke, yes. Oh, nice, cool.
Why should you never trust locomotives? Why should you never trust trains? Because they have locomotives.
Oh. All right, cool. We're going back here now. Dun, 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 dun. I'm excited for this one.
All right, why was Harry Potter sliding down the hill? JK, he was going.
That's a good one. I like it. Thank you. So are we looking? We're feeling. I think. Oh, almost there. All right, cool. I think we maybe have time for one more. Carter, do you have any jokes? I can run over there. Are you mic'd up? Oh, over here. All right, cool. Okay, we'll do two. Why not?
Where did Hook get his hook hand from? The second-hand store.
All right, everybody. Why did Carter do this conference? Why? I have no fucking idea.
Well, I have an idea because this is an amazing community, obviously. Yeah. But we're good to go?
Yeah, I think
cool.
we're good.
Go for it.
Thank
Welcome,
you.
Joyce. Yeah.
Hello, everyone. Thank you for showing up to this particular talk. And if I'm not mistaken, I am standing between you and recess. Is that correct? Yeah, so I'll try to be quick. I just set the timer there. Hello, everyone. My name is Joyce. I'm the head of developer relations at Postman, an API platform used by 20 million devs. This is my first time at Cascadia. Can I get a show of hands? Who has used Postman before? Oh God, these lights are bright. Okay, amazing. All right, so I have worked at Postman for the last 5 years. I've been rolling around in APIs for a really long time. Well, 5 years is a long time. For enough time, and so I decided to give a talk about reverse engineering a private API. Who has ever tried to do this? Leave your hand up if you were successful. Okay, I'll be asking you guys for help. So we're going to be talking about why reverse engineer APIs at all. And then we'll get our hands dirty. We will capture network traffic, individual requests, session data, as well as start streaming network traffic into a proxy. And then we can capture it and inspect all we want, but we want to be able to replay the API calls when we want to. So we'll take a look at some scenarios like cookie-based auth. I won't talk about SSL cert because Eddie just talked about that. And then we'll talk about spoofing client attributes and learning how to replay it in your own bot script, whatever you want to replay in. All right, so reverse engineering, if you're not familiar with it, is also called back engineering. It's the process by which a man-made object is deconstructed to reveal what's going on inside. But if you don't have access to the object or the thing that you're trying to take apart, then you might be reverse engineering it. So another word, here's a synonym used to describe reverse engineering, is also called hacking. And hacking has a little bit of an iffy connotation, but Alyssa Knight, she calls herself a reformed API hacker, says all hacking is figuring out how something works. Sending a stimulus to an application that the developer that built the application, did not anticipate. For the rest of us, why would we reverse engineer an API? Why do it? Okay, so here's some examples. This hit Hacker News a while back, but somebody hacked Papa John's API. They wanted extra bacon and duplicate item. You couldn't, they actually client-side validated duplicate items. However, duplicate item as a property on the bacon object was not validated. So somebody's able to get extra bacon. Here's another example. This person wrote about it, huge fan of couch surfing. This is Airbnb before Airbnb was a thing. You can stay on other people's couches. Lived in the French Riviera, really popular couch, and was flooded with all these requests. He wanted a calendar and a filter. He wanted custom functionality, and when he reached out to the couch surfing people, they said, unfortunately, we're not gonna make an API for you to do this kind of stuff. They wanted to control what you could do with their back end. Another example, Starbucks. How many people like Starbucks? And like, you know what's possible with APIs, but does the Starbucks team? Sorry if anybody here is from Starbucks, but there's selfish reasons that you want to be able to reverse engineer an API for. Okay, now we're getting into like the seedier side of reverse engineering. This is a subreddit specifically for defeating cheat detection. Okay, how many people have looked up cheat codes? This is reverse engineering games. And here's another one, cheating at life. So if anyone's ever done online like app dating, you have to use your eyes, you have to look at the person, you have to read, decide if you like or dislike somebody. It's super tedious, super manual. What if you could just script that? You want to filter for somebody that has cat gifs and then take an action. I don't know which way is the action, but you want to be able to script that. So you can see the date on here. Tinder has definitely covered up that vulnerability, but there's always reasons why you're like, oh, I wish I could reverse engineer that. And this is one I wrote. This is probably not the crowd for it, but if anyone's ever tried to go camping at Yosemite, there's good camping spots and like less good camping spots. And they've changed the way they do it now, but they used to announce, okay, camping spots are open, and within 60 seconds, all those camping spots are booked. How can that be? I physically can't click through their interface. Well, they have a web API. So I figured out a way to book a campsite in Yosemite Valley by reverse engineering APIs. Okay, sorry if that inflamed anybody here. I know this is probably not the crowd for it. Okay, so lots of reasons to reverse engineer an API. Maybe you're an API consumer. Okay, the engineering team is really slow. They're not building the features that you want. Maybe you want to build your own custom app bot or entire application. Or maybe you just have selfish reasons that you want to reverse engineer an API. So that's for API consumers. For an API producer, there's legitimate reasons too that you might do this as part of your work. So if you are a security engineer or a quality engineer, you probably are good and have a good mindset for reverse engineering. And you can use it to diagnose and debug issues. You can use it to do penetration testing and performance testing. Okay. So if you're an API consumer, I'm guessing the majority of us here are API consumers that want to learn a little bit more about reverse engineering. Here is my legal disclaimer here. When you're reverse engineering an API that's not yours, review the terms of service. You can get sued, banned, or issued a cease and desist, whatever. But if you publicly share the code, you can have criminal liability too. So here's the rule of thumb, responsible disclosure. If you find a vulnerability, you always want to report it to the company first and let them have an opportunity to patch that first. And an opportunity can be immediately, it can be a year. It's quite subjective, and if you're curious about this, the Electronic Frontier Foundation's Coders' Rights Project is a good resource to look into. And TLDR, she said something about legal disclaimer, criminal disclaimer. Be ethical on a case-by-case basis. Consider the broader stakeholders. So that Yosemite example I told you about, I'm kind of proud of it, but I'm kind of not, because people get really, really angry about that kind of thing. And was I cheating at life because I beat somebody, I knew something about APIs and now I'm advantaged? Okay, so be ethical. All right, let's get to getting our hands dirty. Capturing network traffic. The first thing we'll take a look at is visibility of API requests. We'll use Chrome DevTools, curl requests, and okay, let's hope this works, because I recorded all of this, so all my tokens could be expired by the time you all see this. Okay, so is it working? Nice. Okay, so here I am on TikTok.com. And I'm scrolling, I'm opening up Chrome DevTools, and here's all the network calls that are coming through. Most of us have probably seen this, but the first time I saw this, my mind was just blown. How does a website work? So these are all the different network calls you can filter by method, status code, and if you right-click on it, you can copy it as, it went a little fast, but you can copy it as curl and import it into Postman as text. So this is what that curl command looks like. You can be in terminal, or you can bring it into a graphical user interface. And then the graphical user interface will divvy everything out by parameter. So there's a lot of stuff that goes into this one API call for TikTok. And some of it we can see. Some of it, the keys are very clearly written. TikTok has a couple that are very obscured where it's just single letter properties. And then we can send our call, replay it, and inspect the response that comes back. Okay, So you can always copy an API call as curl and import it into whatever your favorite tool is as raw text. I don't know, how do I, okay, there we go. Okay, so when I right-clicked on copy as curl, there's actually a lot of different formats that you can copy it as. So that's a single API request. Let's expand our search to session details, an entire session. And so one of the options there was har files. And you can also use curl to capture an entire session. But now we'll take a look at HTTP archive format har files, extension har. There's probably a joke here somewhere, but I didn't think enough about pirates. Okay, so let's take a look at saving all as har. We are still browsing TikTok. And now when we copy, we're saving all as har with content. And now we're going to save it as a file, a local file. And don't take a look at my local files. Let me describe to you with words what would be happening here. Have you failed me, Google Slides? Oh, this actually looks really cool on the video too. Let me describe to you with words, unfortunately. So you can import that har file, and what you'll see is a collection that has bazillions of however many API calls that are being made in the back end. Well, that's unfortunate. Okay, let's go on to the next one.
You're importing into Postman here?
Yes, you're importing the har file into Postman. And you can, remember, you can use curl. You saw all those copy as formats, so you can use your favorite format. Curl can be either an individual API call or session, and har is typically used for session replay. What if none of them work again? Okay. Oh, good. I have a, well, no, I didn't get that screenshot. Okay, so this is save content as har file. So we took a look at an API, individual API call. We took a look at a session. But now let's start streaming all the API requests. And we can inspect traffic coming from client apps like web browser. We were just looking at TikTok.com. Mobile apps, we can look at TikTok app and any kind of connected devices. So we're going to be using a web proxy. It's a server, and I think the image is a little bit more clear than the text. But it's a proxy server, a substitute server that sits in between the client application. In the picture, it's a mobile app or a mobile device. So the web proxy is going to intercept the traffic going on its way to the website server. Okay, so we're using web browser, but any HTTP client app, like a mobile app, I did a live stream where I hacked my Roomba. As long as you're on the same local network, you should be able to web proxy your network calls. And again, I'll show you using Postman, but there's a lot of free tools that are very, very popular. There's a ton more than this, but you have man-in-the-middle proxy, Fiddler, Burp. All of these have some free version of a web proxy that you can use. So let's use Postman. Okay, so I'm in the Chrome browser. I installed an extension called Postman Interceptor. And when I turn on the proxy, you can see all, okay, so none of these are on TikTok. I don't know if you can see that well, but those are all the, just back end, all the Chrome windows that I have open. When I apply filters, I can actually filter by TikTok.com or subdomains. And as you scroll, you'll see those AJAX calls. Filtering in the back end. Okay. So that's using browser extensions. Let's click through. That's a screenshot, so you can see the various post and get calls. All right, so that's a flood of calls just coming in through your extension. How do you snap one of those up? Let's proxy that into a Postman collection, and a collection is just a group of your API calls. If you had seen the har file import, you would have seen how that looks. So here I am on the left side, I have my interceptor on the Chrome browser. On the right side, I'll just create a new collection to contain all of my network calls. And I'm on the desktop app, slightly different. It's not Chrome catching from Chrome. And then at the very bottom, you can capture requests. I'm zoomed in real hard, so having trouble there. And then I'm already connected. You see it on the left side. And now I can filter, proxy them all into this collection. Hopefully you'll get to see what that looks like, since you didn't see the har. Okay, so on the right is going to be all the API calls that are coming in. And now I'm back in Chrome. I'm browsing. Oh, this looks interesting. What's this? Okay, so a lot of get calls, a lot of post calls. And then it's actually really hard to see here because it's piling up at the bottom. But if you can see the number of requests, 21, 22, 23, 24, that's the number of back-end calls that are hitting TikTok servers. 37, 38. I'm narrating in case people can't see the number. Okay, so let's stop our session. That was a really short session. And then now you have your get calls and your post calls. Snap that picture in your mind for a second. Does anyone know why TikTok.com has so many post calls? Yeah, so whoever said that over there, I think that's probably true. I took a peek at some of those post calls, and it's a ton of metadata. Your operating system, your device, your battery life, just all sorts of information. Your position that you're like scrolling from. There's a lot of data that's being sent to TikTok servers. Okay. Okay, so this is just a screenshot, just in case that went a little fast. All we did was proxy, our client in this case was Chrome browser, and we proxied those web calls over to Postman and saved them in a collection so that we could replay them and poke it, update all the parameters and poke at it. Okay, let's take a look. I keep losing my cursor because I have a screenshot of a cursor. Okay, so we talked about different types of apps. For mobile apps are exactly the same. So here I have a screenshot of, I'm on Android, so all you need to do is check if your proxy, in this case we're using Postman on a local machine, a MacBook, we're looking up our IP address and then pointing our mobile device to that same IP address. We're on the same local network, we're pointing it to the same IP address and port. And all of that traffic information will come through from your mobile app. It's pretty neat if you've never sniffed data before. Okay. So we looked at an individual API request, a broader session, and then we looked at a stream of API requests so that you can go multi-domain and multi-session, multi-device. You can aggregate all of that information. And I've actually done that before to document a poorly documented API. So if you don't have documentation, if your engineers don't have something that you can go look at, you can load up the website, set up the proxy, start clicking around. Click on the profile, add a comment, edit a comment, and look at all those web APIs that the engineers are using on the back end. All right. Now it's time to replay. So one of the toughest things when you're reverse engineering API is you saw me intercept or copy as curl a single API call. And then I hit send, and it worked immediately. It was like magic. But anybody, those 4 people that had their hand held up, know if you want to hit send again and you wait an hour or you wait a day or you wait a week, it's probably not going to work, right? So there's certain access tokens that might expire or time out. Let's talk about a couple different scenarios. The first one is cookie-based auth. Okay, so for cookie-based auth, when a user enters in their auth information, their credentials, into a browser, the browser will send it over to the servers. The server is going to return a cookie, log that session ID, and then send it back to the browser. The browser is going to keep that cookie until you clear your cookies, folks. And then the browser and the server can have this conversation that records the same session ID. Okay, so let's take a look at how to do that manually first. Okay, so I'm going to hit github.com. And there's a tab called cookies. The cookies are what's being sent back from the GitHub servers. And when I preview what github.com looks like, you can see I'm not signed in. So I can manually add my cookies by domain and start syncing. So what I'm syncing with right now is the Chrome browser, and I'm logged in on Chrome. So now when I hit that call again, I have a bazillion more cookies, and it went a little quick, but under the response body, you saw I was logged in. So it's syncing your cookies from your Chrome session to Postman. And if you take a look, man, that went really fast, but I don't know how to pause it. If you take a look at what was in the console, GitHub.com sent back a ton of cookies. And then one of those response headers is going to be set cookie. That's going to be the cookie that you include in all of your requests going forward for cookie-based auth. Okay. Yeah, and I don't know how to make it not play again either. Okay, so here's a screenshot. Fortunately, I don't think I'm revealing any personal information here, but here's the cookies that you would then set for your other requests. Cookies coming back from the server. Okay. All right, and then one of the things that I think is difficult, because I answer a lot of Stack Overflow questions, I answer a lot of forum questions, and I always get, it works in Postman, but it doesn't work in my app. Sometimes I think tools are so good at abstracting what the problem is and helping you get that success, that 200 OK or whatever success code you're looking for, but it abstracts it so much that you're not able to see exactly what's happening. So on the right side, you can see here is the actual API call that's, oh gosh, it's in curl, but you can choose whatever language or framework you're looking for. So you can see exactly how to format that API call so that it works. And then I think I have a screenshot of it later, but also just take a look at the raw request and raw response that's coming back. Sometimes the syntax highlighting futzes me up, and so I think just being able to look at the raw and the pretty version is helpful. All right, so let's talk about spoofing client attributes. Let's pretend to be something that we're not so that we can fool the servers. So we'll be taking a look at user agent header to access things like dynamic websites. So dynamic websites are based on code that's rendered. So in the old-timey days, the server rendered everything and then sent it over. And now they're relying on the client to render a lot of this code. So if I just put in github.com or linkedin.com, wait, we don't like LinkedIn here? If I just put in one of those dynamic websites and I inspect the HTML elements, I expand, a lot of the stuff isn't going to be there the way you see in a browser. And so how do we spoof it? I actually came upon this because I was trying to scrape Postman data, and I couldn't, and the API didn't give me what I wanted. So I don't think I have a video here. Actually, did anyone not see that? Does anybody know what I should do? Did everyone see that? What should I do for user agent? Any hypotheses? How can I see dynamically rendered data? You saw it. Okay, if you didn't see it, kudos to you, because that was mind-blowing. So when you send, there's two rows I want you to look at in the screenshot. The first one is the checked, well, they're both checked. The top user agent that has the strike through it. Whenever you send a call through Postman, Postman automatically creates these headers, these temporary headers, and says, hey, it's coming from Postman, I'm over here. You can override that by adding another user agent, Googlebot. And the reason why this works for Postman.com, like a lot of sites, does anyone know why? Googlebot? Everyone wants to be scraped by Google, right? So for SEO equity, Postman will currently render all the code, render all the content about once a week so that it can get scraped. So if I am sending something to Postman.com and I update my user agent, I can then expand all those HTML elements and actually find the data that I would see in a Chrome browser. Okay, so you never know what the server will accept back, so it can't hurt to just try. Okay, so the very last point I want to make here is, I kind of already said it, but it's totally fine to replay something in your favorite Postman or graphical user interface or whatever you're using, but a lot of times you want to then roll it into into code, into a script, into a bot, into an integration. And so I already showed you that image of the code snippet that you can generate. And I don't have it here, but also just look at the console. Almost every tool you use will have a console, so you can take a look at the raw data that's being sent. Okay, so key takeaways. We talked about why reverse engineer an API. It's going to be different if you're an API consumer or an API producer, but there's legitimate reasons for both, and there's kind of illegitimate reasons for both too. And we took a look at dev tools, curl, har files, web proxies, lots of different types of tools. And the reason why there's so many different formats and so many tools you might be using, we looked at a Chrome extension too. There's so many different use cases, and every API is going to be different. So the 4 people that had their hand up that successfully reverse engineered a private API, I think it takes a lot of the puzzle solving mindset, one that I don't have, right? If I didn't want to go camping, I never would have just banged my head against an API for so long. But if you have that kind of intuition and hypothesis in your head, I bet, well, I made an API once like this. You don't know how they're validating stuff on the tail end, and you don't have a lot of visibility. But that's the reverse engineering part. So the last thing I'll close with is do not violate your terms and conditions. Always be ethical. Be excellent to each other. And then I will just end with something that Eddie had such a great talk, and I feel so smart after watching Eddie's talk. I want to end with something that'll make you feel smart too. So hacking, the definition of it is sending a stimulus to the application that the developer that made the application did not anticipate. Okay? So Hiram's law, this is a Google engineer, Hiram Wright, and he said at scale, anything you offer through an API can and will be used by someone out there. Even if you didn't intend for them to update that bacon object, somebody's going to find that out and come to rely on it. So here's a relevant XKCD that illustrates Hiram's law. I'll just read it out loud. So somebody's releasing changes to version 10. The CPU no longer overheats when you hold down spacebar. And longtime user complains, this update broke my workflow. My control key is hard to reach, so I hold spacebar instead. And I configured Emacs to interpret a rapid temperature rise as control. And that's just their workflow, man. You gotta know that you're gonna be breaking a flow, and other people are gonna try to tap into undocumented aspects of your API. And that's all I have. Thank you very much for your time. I'm so sorry, 30 seconds, 30 seconds. I do have a bobblehead here, so the first person to find me in real life, and I have a second one, the first person to find Kate in Gather online, so people watching at home, the first person to say how you can order extra bacon at Papa John's correctly gets a bobblehead. That's it. Yay.
That was so awesome. When Joyce submitted her proposal to our CFP, I jumped out of my chair. I was so excited to hear this talk. I think the CFP submission made it sound like it was going to be a little bit more a little bit naughty and evil, and I think she did a really great job of sticking to using hacking for good. All right, just give me 1 second, folks. All right, we should have this stuff up on the screen. Got a clicker, I got a mic. I am your happy, helpful, exhausted lead organizer, Carter Rabasa. My pronouns have not changed, they're still he, him. Wow, we have gotten to the end of the first day of talks at CascadiaJS 2022. Big round of applause for all these amazing speakers. So there's a couple things I want to talk about. This kind of sort of day closing is going to be a two-parter. We're We're going to do one part for you and everybody online, and then we're going to say goodbye to our friends online, and then we're going to have a lot of very important information for the rest of the day here at Sunriver. So please do not step away. One thing I wanted to share is that our friends at Mux have built this awesome video booth for us here in person, but they've also released a version that anybody can use on the internet. So I am going to very quickly, with all of your help, record a quick little video selfie. So on the count of 3, everybody scream. 1, 2, 3, scream! Okay. I probably should have done that differently. But anyway, if you are at home and you are watching this in the comfort of your bedroom, living room, backyard, you can go to, there's a link, this is linked off of our website, and you can go record your own little video selfie and share it. Share it on Twitter, share it in Discord. It's just a really great way to sort of see what people look like and sort of share a little bit of your personality. So definitely check that out. I wanted to reiterate that we have like a lot of different channels that people can use to connect with folks. Discord being a great one. People who are here, people who are participating in the virtual event, get on Discord. Every single one of these awesome speakers has an AMA channel. And it's really great. It's good for like asynchronous stuff. Like while you're watching the talk, ask a question. And I'm sure our speakers will circle back at some point and answer your question when they have a second. We also have sponsors. All have channels set up where you can go talk to them about about whatever you want to talk to them about. So definitely visit them and say hi. But there's like tons and tons of other channels, and there's actually even a karaoke channel. So if you're excited about karaoke tomorrow night, there is a channel for you. So definitely go explore the Discord. Putting this URL up on the website because surprisingly, I keep getting asked questions about like what time is lunch and where is it? I swear to God, all of this information is on the internet at that website, as well as we can possibly render it for English-speaking people. Yeah, go check it out. And by the way, it's also I think it's just really helpful to kind of know what's going on like in the future and just sort of pre-plan a little bit, right? You don't want to get caught off guard that there's a workshop you really care about going on at the same time as a talk that you wanted to see, right? So, kind of plan, maybe plan the rest of this day or start planning tomorrow. Gather. So here at Sunriver Resort, we have our job fair and social kicking off after dinner at 7:30. But I just wanted to make sure the folks, watching on this stream knew that we're going to definitely encourage folks to show, go get some dinner, maybe hang out with some real people in IRL. But feel free to come back together and kind of party, on the internet, starting at 7:30 PT. Pretty sure Kate will be there, and she'd really love to see you. And that is it for all of our friends online, and we will see you for day 2. Yay! Everyone just hang tight. Can I get representatives from job fair companies up here on the right?